9.1, we're going out of order here. We did 9.2 first because multiplying and dividing fractions is easier than adding and subtracting fractions. Okay? Why is multiplying and dividing easier than adding and subtracting? It's more simple. The thing about adding and subtracting is we have to have common denominators. Multiplying and dividing, we don't care if the denominators match or not. We're just going to factor and start canceling stuff anyways. But adding and subtracting, we cannot physically, you know how yesterday we would make one giant fraction? We can't make one giant fraction unless we have common denominators. So that makes it a little bit more of a tricky process. Now, this is a problem from like, what, 3rd grade, 4th grade, something like that. When you are adding two fractions, if the denominators match, then the denominator stays. You add the numerators. And then do we reduce our answer? Always. Okay? So one thing I didn't really get to explain very much yesterday, which I'll explain here, is this fraction right here means you have a pizza, you cut it into 5 pieces, and you ate 3 of them. That's what that means. This one right here means you have a pizza, you cut it into 5 pieces, and you ate 2 of them. Now, in this particular circumstance, that could be the same pizza, right? Because they're both cut into 5 pieces. So if you ate 3 pieces, and then you came back and from that same pizza, you ate 2 more pieces, guess what? You ate the whole pizza. That's how we did that problem right there. Okay? Real quickly about the excluded values. If I have a fraction like this, that means I have a pizza, I cut it into 4 pieces, and I ate 1 of them. If I have something like this, I cut a pizza into 7 pieces, and I ate 2 of them. If I have something like this, I cut a pizza into 8 pieces, and I ate none of it. I cut a pizza into 0 pieces? How do I do that? Because if I don't cut it, it's not 0 pieces, it's 1 piece, isn't it? So this is where our excluded values circumstance comes from. It's fine to have a 0 on the top because you can eat no pizza and that's fine. But the 0 on the bottom, that's an impossible pizza situation. Okay? That's why we need to look when our denominator equals 0. In this example right here, will my denominators ever equal 0? No, because there's no x values. They're always going to be 5 based on that. Or it's going to simplify to 1. Okay? So that's what we need to keep in mind when we're thinking about our excluded values. Okay? Let's see. Here is an example with variables. Do you notice that the denominators match? 5x, 5x. What does that give me? 5x in the denominator at the end. Is that flashing bothering you in the video? Okay, because it's bothering me over here. 3 plus 2 is 5. And our canceling rules still apply just like they did yesterday. So now that I've got it all in one fraction, I can cancel out those 5s. Please don't say that my answer is x, because my answer is not x. My answer is an x on the bottom, and what on the top? 1, if everything disappears. Now this one we have to talk about excluded values because there's an x on the bottom. So if I said, oh, solve this when x equals 3, you could solve it, couldn't you? What number could I not tell you x could equal? 0. Because if I said x equals 0, we have impossible pizza situations and we can't do anything with that. So my excluded value, the only thing I can't tell you x to equal, I don't know if that made sense, that sentence or not. The only number that it can't be is 0. Okay? When we have monomials on the bottom, it's usually just 0 is our excluded value. It usually works out nicely like that. Just set it down, please. Okay? So? Okay. Now let's look at ones with not common denominators. Uncommon, unlike. Those are the ones that are a pain in the butt. Because if I have a pizza and I cut it into 5 pieces and I ate 3 of them, I have to have a whole nother pizza to cut it in 3 pieces, don't I? I can't use the same pizza anymore. So we have to talk about this in terms of a pizza that's cut in the same pieces. So we have to find a common denominator. Now, when we're talking about plain old numbers, I always like to think, okay, what is the smallest number that can be divided by both 5 and 3? 15. That's going to be my common denominator there. So I have to actually rewrite these with a 15 as the denominator. So let's see. If I have a pizza cut in 5 pieces, and I need to take that pizza cut in 5 pieces, and I now need to cut it into 15 pieces, what do I have to do? I have to multiply that 5 by a what to get the 15? 3. And if I multiply the denominator, I also have to multiply the numerator. So that means that I get 9 on the top. This is, I like to think about this as unreducing. I am unsimplifying a fraction so that I have common denominators. Because if you look at this, if you divide both of these by 3, it reduces to 3/5. Do you see that? So I'm going backwards in the reducing process so that I can combine the fractions and then reduce at the end. So how can I unreduce this guy? I have to multiply the 3 by what to get 15? 5. So I have to do the same thing to the top, and 2 times 5 is? Now I have common denominator, so I can treat it like the first problem. Now it's already written out here. 9 plus 10 on the top gives me over 15. And can that reduce? No. 19 is prime, so I can't reduce that. Is that more or less than a whole pizza? That's more than a whole pizza. I had to get two pizzas, cut them into 15 pieces each, and I ate a whole pizza plus 4 pieces off the other. That's what's going on there. Okay? Do we like pizza with fractions? It takes us back to like when we first learned fractions. Okay, now over here, similar problem, but we have x's and y's. Oh, do I have to talk about excluded values here? Okay, look at my denominators. Are there any x's or y's? Over here on the left? No x's and y's, so I don't need to talk about excluded values here. Doesn't matter. Over here, I will have to talk about excluded values. So, 5 and 3. I'm going to find the least common denominator, the LCD, from 5 and 3 first, and then I'll deal with the letters. So from 5 and 3, the smallest number divisible by both is 15. So I'm actually going to kind of like rewrite the problem. Do you see how it's fraction plus fraction? I have fraction plus fraction there, because I have to rewrite those fractions with the common denominator before I can add them. Now let's talk about the x and the y. What is the smallest number divisible by both of them? Well, it's going to be the number that contains both of them. So another way of thinking about that is, how many x's do you see? Actually, let me rephrase that. What is the smallest, nope, what is the largest amount of x's you see in any denominator? Just 1, right? So my common denominator has to have 1. If the largest number, if this was an x squared, and maybe my other one had an x, the largest one represented in a denominator would have been x squared, and I have to include that in my denominator, my least common denominator. What is the largest number of y's that are in any denominator? 1. So my least common denominator is 15xy. So? Yeah, getting there? Okay. So now let's talk about what we're multiplying by. What do I have to multiply this denominator by to get to that common denominator? I have to multiply by 3y. So if I multiply the top by 3y, what does that give me on the top? 9y. Do I want to reduce and cancel those y's out? No, that would defeat the whole purpose of just putting the y on there to have a common denominator, right? That would undo what I just did. Next one, what do I have to multiply 3y by to get this guy? Times 5x. So if I multiply the top by 5x, what does that give me? 10x. Now I have a common denominator, yes? So what do I have on the top? I have 9y plus 10x, right? All over 15xy. right? Because they keep the common denominator. Now, the last thing I have to check at this point, I'm at this place on my notes. Remember these where after I've added, now I'm here, so I need to check and see, can I factor anything to simplify it? Can I factor anything on the top or the bottom here? The bottom, no, because I can't do a monomial. But what about the top? Can I factor that? They don't have anything in common, do they? So I can't factor that. If I can't factor, that means I am done. Now, let's talk excluded values. Excluded values have to come from anywhere there's a denominator in the problem. So there's a denominator way back at the beginning in the original problem. There's two denominators, right? And then the only other denominator listed happens to be the same here, here, and here. Do you see that? So, right here with my 5x, what can x not equal? 0, because if I told you figure this out when x equals 0, you have an impossible pizza situation right there, so x cannot equal 0. That's the only x value I cannot have you plug in. Right here, what can y not equal? Y can't equal 0 for the same reason. It would make this fraction an impossible pizza situation. So I've covered 2 of the 3 denominators. These 3 are all the same, so I only have to talk about it once. If I have 15xy together, are there any new numbers added to my list of excluded values? No, because x equaling 0 would make that 0, and y equaling 0 would make that 0. So those are my only 2 excluded values in this point. Okay. Now, is subtracting any different? The only difference is instead of a plus 10x, you would have minus 10x in this one. That's the only difference. Okay. So this next example shows us a subtraction problem. Let's go ahead and do it so we get a little more practice with this least common denominator thing, because that's the hardest part of this problem. So 5 and 15, what is the smallest number divisible by both of those? Well, the smallest number divisible by both of those is 15, right? Yeah? What if 15 didn't come up first thing in your mind and you were sitting there going, okay, I know 30 is divisible by 15 and it's divisible by 5. What if you use 30? Is that okay? It is okay, but it's not the least common denominator. It's a common denominator, but not the least one, which means that you could end up dealing with larger numbers and you could have more simplifying to do at the end. Will it work? Yes. It just might be more work to get there. All right? So, if I change these, fraction minus fraction, I need that common denominator of 15. What do I need to multiply the 5 by to get to 15? 3. So I multiply the top by 3, and that gives me 9. What do I need to multiply the bottom here by? 1. Or another way I could think about it is I'm just leaving that one, right? It's already got that denominator. So if I take the top and multiply it by 1, I get 2. So 9 minus 2 on the top, that's from right here. What does that give me? 7 over 15. Do I need to talk about excluded values for this problem? No, why not? No variables. If there's no variables, there's no excluded values. Okay? All right, let's look at the next one. What would my least common denominator be? Fraction minus fraction. Between 5 and 15, it has to be 15. Now, there's an x here and an x there. Thankfully, they both have the same exponent on them, don't they? They're both a plain old x, which means that I just have to have an x here represented. Now, some people will say, can't I just multiply them together and get x squared? Yes, that will get you a common denominator, but not the least common denominator. I have a y here and no y there, so which one has a higher exponent? The one with a y, right? So I have to have y also in my LCD. Okay. So, 5x. What do I have to multiply this denominator by to change it to 15xy? Times 3y. So I have to multiply the top by 3y also, and that gives me 9y. What do I have to multiply this one by? Nothing. I can just keep it, right? Or if I want to think about it multiplying, I can multiply by 1 like I did here. So the top is just going to be the same. So let's see, I have 9y minus 2 on the top now, and 15xy on the bottom. So I just took two fractions, and this represents the one fraction answer of the subtraction. Now, can I factor anything to simplify? Nope, can't factor the top. Bottom's a monomial. We can't factor a monomial. So I'm done right there. Now let's talk excluded values. How many different denominators do you see in this problem? From start to finish. I only see 2. I see 5x, and then every other fraction has this 15xy. So 2 different denominators that I need to talk about. So from 5x, what is my excluded value? X can't equal 0. Because 5 times 0 is 0, there's our impossible pizza. What about from 15xy? What can x not equal? 0, which I've already got. What can y not equal? Also 0. So those are my 2 excluded values. Whenever your denominator is a monomial, it's either something like this on the left, where it's all numbers on the bottom and there are no excluded values, or it's usually this circumstance where x can't equal 0 and y can't equal 0. Okay? All right, let's try a little trickier here. Okay, I have an addition problem. I have 2 denominators, but this time we're not dealing with denominators that are only monomials. Right? You guys know what I'm saying when I say monomials, right? Learned that on day 1, just one term. Okay, all of these ones, monomial, 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 monomial. All of a sudden we get to one that doesn't have a monomial. So we got to figure out how to find the LCD when we don't have a monomial on the bottom. This one, I have a monomial, I'm good. This one, in order to find my LCD, I have to factor. We only want to factor the bottom at this point. We will factor the top later if we can, but right now we are only concerned with denominators to get that common denominator. So how can I factor this? I can take out a 3x, and what would be left inside? Plus 1, right? So for the remainder of the problem, I am not going to be looking at this form of the denominator. I'm only going to be looking at the factored form of that denominator. Make sense? Now, my least common denominator. I'm going to look at my monomials first, those 2. And just like I did above, I need to find the LCD from these 2 parts. So with 9 and 3, what would be in the LCD? What's the smallest number divisible by both? 9. Okay. Between x and x squared, what's the highest denominator? The largest denominator, the largest exponent? X to the second, that's the one I got to use. Now, Mrs. Franken, can't I just multiply them together and get x to the third? Sure, but that will not get you the least common denominator. It will get you a common denominator. And this is asking for the least. Now, parentheses. Every parentheses represented must be in my LCD. So thankfully, there's only one parentheses represented right here. That's the one that's got to go into my LCD. So that's what my LCD is going to be. So before we get too confused in this problem, let's go ahead and state our excluded values. Because if I look here, 9x squared, what would that make? What would make that equal to 0? If I told you x was equal to 0, right? Because 9 times 0 squared is 0. 0 times whatever that ends up being is still 0. That's an excluded value. What would make this equal to 0? -1, right? -1 plus 1 is 0. So far I have those 2 excluded values. From the original, what's the excluded value here? 0, which is on my list. From here, I have 2. I would have 0 out here, and I would have -1 in there, so those are my 2 there. So I think that's probably my only list, because for the rest of the problem, I'm going to have this as my denominator. So, fraction plus fraction, and both of these new fractions need to have my LCD. 9x squared parentheses x plus 1. It's going to get ugly before it gets nice again. Okay? So, let's see if going to a different color helps here at all. What do I need to multiply the first fraction by? Keep in mind, this was the original denominator. I need this denominator to now look like this. So what do I need to multiply it by? It's got the 9. It's got the x squared. It's missing the x plus 1. So I need to multiply this by x plus 1 in order for those denominators to be the same. So if I multiply the top by x plus 1, I have 7 parentheses x plus 1. Does that make sense? In other words, if I can, in my brain, reduce this fraction by canceling out those x plus 1s, I should have the original fraction there. Yeah? Okay. Now, this one has the x plus 1, but it doesn't have the 9x squared. So what do I need to multiply by in order to make this a 9x squared? 3x. So I have to multiply the top by 3x also, and what does that give me? 3x squared. That is the hardest part of the problem, is that process right there. So, down here, I now have 9x squared, x plus 1, and let's see what we've got going on the top. Now, just to make sure we're all clear, I'm going to go to a little piece of scratch paper here, if I can get it. Yep. And I'm going to look at just this right here. This is 7x plus 7 plus 3x squared. Correct? So when I combine both numerators, this is what I get. Now really, I shouldn't write it in this order. I should write it like this. 3x squared plus 7x plus 7. Why should I write it in that order? Because it's standard form. So I have 3x squared plus 7x plus 7. You okay with that as my answer? There's one thing I have to check before I can be done, though. If I can factor that top, I might be able to cancel something. So looking at the top again, that's the 3x squared plus 7x plus 7. Do they have anything in common I can take out? No. Can I snowflake it? 3 times 7 would be 21, and then 7. I need two numbers that multiply to get 21 and add to get 7. The only numbers that will multiply to get 21 are 1 and 21 and 3 and 7. I don't think either of those will ever add to get 7, no matter how I put positives and negatives in there, right? So if I can't snowflake, that means it can't be factored. That is my final answer. Okay. Can I cancel the 3 and the 9? Or the x squared and the x squared? Why not? I have pluses that are not in parentheses, right? So I have to think of this as though it is a parentheses all of itself. And I can't cancel out part of parentheses. Okay? So? Did I add any new excluded values? No, because I still have that same answer, so my excluded values have not changed. So? Okay, let's do a subtraction problem. I have to start off by finding my LCD. If I have two denominators that are not monomials, what do I have to do before I can find my LCD? Factor them. So, I'm ignoring the top right now. I'm not going to factor anything on the top right now. I'm just going to leave it as is for now. Can I factor 3x minus 15? I can take out a 3, and I'm left with x minus 5, right? So for the rest of the problem, I am not going to look at that form of the denominator. I'm only going to look at the factored form of the denominator. How about this one? X squared minus 4x minus 5. Can I factor that? I think I can snowflake that. Negative 5 and negative 4. Negative 5 and positive 1, correct? They will multiply to get negative 5 and add to get negative 4. X and x, so let's see, I have x minus 5 and x plus 1. So for the rest of the problem, I'm not going to be looking at that form. I'm going to be looking only at the factored form. Okay? Let's talk LCD. What is not in parentheses? 3. That's part of my LCD. Now I need all parentheses that are represented. So how many different parentheses do you see? 2 different parentheses. Do either of them have an exponent on them? X minus 5 doesn't have an exponent on it. There are 2 of them, but I do not see an x minus 5 squared, right? I don't combine them. So since they're both represented only once, I just take 1. Same reason up here when we had 2 x's, we didn't get x squared, we just took x, right? It was only when we had an x squared and an x that we took an x squared. So I have both of these as only 1 power, so I'm only taking 1. What other parentheses is represented? X plus 1. So that's my LCD. Let's talk excluded values. What can x not be here? 5. What about here? Negative 1. Because it can't be 5 again, but I already have that listed. And then that would give me negative 1. Why did I not ask about the 3? If there's no x there, there's no excluded value there. Am I going to encounter any other excluded values? Nope, because everything's going to be rewritten with this LCD. And I've got everything covered from the LCD. So there's my excluded values. And let's rewrite our fraction. So I have fraction minus fraction. That's what my problem is. And I now need to change this problem so that both of them have this LCD. So this is the first time I'm touching the numerators. You with me? Okay. How do I get from here to this denominator? What do I have to multiply by? X plus 1. So if I have on the top x plus 1, I get x parentheses x plus 1. That's what the new denominator or new numerator has to look like. Again, if I cover up what would cancel from those, I should have what the original fraction was. X over 3x minus 5. Got it. That means I did it correctly. What does this denominator need to match this? A 3. So I'm going to multiply this by a 3. Now, could I distribute? Yes, I'm just taking it one step at a time. Okay, so in my next step, I'm going to combine these two. So I'm going to have one fraction with that common denominator. But I have to look at the numerators by themselves now because I'm going to do some work there. So if I go right here, x times x plus 1, that would be x squared plus x, correct? Now I have a minus sign in the middle. Minus. This minus sign, I'm actually going to treat this as though it was a negative 3 that I'm distributing. Does that make sense? So negative 3 times 2x would be negative 6x, and negative 3 times positive 2 would be negative 6. So let's combine our like terms. X squared, what? Minus 5x minus 6? Yeah? So I have x squared minus 5x minus 6. Now I have officially combined both numerators. I've combined any like terms that I have. Am I done with my problem? What do I have to do? I have to see if I can factor the top and cancel anything. So let's see. Can we factor x squared minus 5x minus 6? Negative 6 and negative 5. I think we can. Negative 6 and positive 1. What does that give me? That becomes, I have x minus 6 and x plus 1. And then what was the denominator? 3 parentheses x minus 5 parentheses x plus 1. Do you see anything that cancels? I do. X plus 1's cancel. So finally, I'm left with x minus 6 and 3 parentheses x minus 5. Could you write 3x minus 15 on the bottom? Yes, but I'd rather you didn't. I'd rather you just leave it in the factored form. Okay, questions there? Okay, let's see what we've got going on in the back. I think I have one more example here, and then we have just a conversation about this next one. Okay, so let's do this guy. What do I have to do first? Factor my denominators. How can I factor this guy? Take out a 2, what's left inside? X minus 1. So I'm not going to look at the original denominator, I'm only going to look at the factored form. What about this guy? This is a snowflake, isn't it? 3 and negative 4. What are two numbers that multiply to get 3 and add to get negative 4? Negative 3 and negative 1. So I have x minus 3, x minus 1. So I'm not going to look at the original form. I'm only going to be looking at the factored form. Now, there's no spot over here, but I'm going to write a spot. What is my least common denominator? Can you tell me without me having to talk you through it? 2, x minus 1, and x minus 3. That's my LCD. Let's talk excluded values from there. From my original one right here, what's an excluded value? X can't equal 1. From here, x can't equal 3 and 1 again. And those are the same ones in my LCD, so that should be my excluded values there. All right, fraction plus fraction, and both of these new fractions have to have that LCD. So far, so good? All right, what do I have to multiply this denominator by to get it to match this guy? What's it missing? The x minus 3, so I have to multiply by x minus 3. So up here, I have a binomial, don't I? Can I just write x plus 2 and then the parentheses x minus 3? Can I write it like that? If I write it like this, is the x being multiplied by the x minus 3 at all? No, only the 2 is being distributed, right? So I actually have to put this in parentheses. So when I have a numerator that's more than one term, I have to treat it as though it's in parentheses. Okay? What is this denominator missing that it needs down here? 2. I'm going to multiply by 2. Multiply by 2, that gives me 2 parentheses 2x plus 1. So far, so good? Now I do the adding part. So when I add these, I'm going to get something that has 2 parentheses x minus 1 parentheses x minus 3. And let's look at those numerators. If I look at, I'll try and do it on this paper because I think I have a little more room. If I try and look at my numerators right there, I have x plus 2 parentheses x minus 3 plus 2 parentheses 2x plus 1. Right? This is like something you would have seen on your last test. What do I need to do here? Multiply it out. X times x is x squared. X times negative 3 is negative 3x. Positive 2 times x is positive 2x. Positive 2 times negative 3 is negative 6. What do I have to do over here? Distribute. 2 times 2x is 4x. 2 times 1 is 2. So I have a really long, ugly thing right there, but let's combine like terms and make it reasonable. I have x squared. How many x's do I have? Negative 3 plus 2 is negative 1, plus 4 would be 3x. And then a negative 6 and a positive 2 would be negative 4. So what I have here is x squared plus 3x minus 4, now that I've added those and simplified them. Last thing I have to do, check and see if I can snowflake this. Negative 4 and 3. I think I can have 4 and negative 1, right? 4 times negative 1 is negative 4. 4 plus negative 1 is 3. X and x. So let's see. I now have x plus 4, x minus 1, and on the denominator, 2 parentheses x minus 1 parentheses x minus 3. Cancel, cancel, and I think I'm finally at my answer. X plus 4 on the top. Do I need to put parentheses around it? It's the only thing there, so I don't need parentheses. On the bottom, I have 2 parentheses x minus 3. Do I have any new excluded values here? Yeah. 3 is my excluded value from here. It's already on my list, so I'm still good. Okay, so. All right, this last one is a problem that is already solved for you. The original problem is right here. She went ahead and factored the denominators for you here. And then she rewrote the denominators in factored form, did her combination, and simplified it. My question here is, what are the excluded values? Do I look here for excluded values? No, I only look at the factored form of the denominators. So, from here, what is an excluded value? Negative 7. From here, positive 2. From here, still negative 7, right? Are there any new ones down there? Nope. How about here? How about here? So my excluded values would be negative 7 and 2. And again, if you want to see the process through again, you could, if you wanted to, ignore all this work, try and solve this problem, and then check yourself with the answer there. Okay? All right, your homework is textbook page 366, number 1, 2, 13 to 24, and 29.